Hi guys, welcome back. So this is check understanding number 1 on page 14, wherein we are going to be classifying numbers as to whether they are natural numbers, whole numbers, integers, rationals, or irrationals, and whether they are or is it a real number. Um, for our purpose, most of these numbers, in fact, for this set of numbers, all of the numbers that we have are real numbers. Okay, let's begin. So 12, what is 12 going to be? Well, 12 is a natural number, all right? So 12, oops, sorry. Okay, it should have been this. Okay, 12. Well, it's a natural number. Therefore, it already is a whole number. It's an integer. It's a rational, all right? No, it is not irrational. It's a rational number, okay? What about the root of 8? Well, the root of 8 is irrational, okay? Negative 9.12, what would that be? Negative 9.12. Well, is that a natural number? No. Is that a whole number? No. Is it an integer? No. It is a rational though, because you can turn that into negative 9 and 12 over 100 and then turn it into an improper fraction. So it is rational, all right? All of these are real numbers again, okay? 24.35 with a bar on top of the 35. Well, that means that the 0.35 or 3500ths that is part of this number is repeating. So it's like 24.35, 35, 35. And any repeating number can be turned into a fraction. That's why it is a rational number. Okay? Rational only. Okay? Negative 13. Is that a natural number? No. Is it a whole number? No. But it is an integer. All right. And since it is an integer, it is a rational. Okay. Well, let's just choose another one here. I don't know. Like this one here, 2.718, whatever. Okay. And it is continuing on. Well, it is not rational because it doesn't end and there is no pattern. Now, take note though, when I turn this into a rational number, this one, it is because it is non-terminating, meaning it is repeating itself and there is a pattern. Okay, this pattern doesn't end. But here, it doesn't end, but there is no pattern. That's why this one is just an irrational number. Okay. Now try the others. Another way to do it is if there's a root symbol, use your calculator. If you are able to get a number and then it terminates, then probably it's a rational number. Okay. So just to summarize, a natural number would be all those numbers which are counting numbers starting from 1, 2, 3, and so on and so forth. The set of whole numbers would be all of those natural numbers, but you would have to add a 0. Okay. The set of integers would be all of the natural numbers, 1, 2, 3, 4, 5, 6, 7, and its opposites, negative 1, negative 2, negative 3, and so on and so forth, and 0. What are rational numbers? A rational number would be any number that can be turned into a fraction, and any natural number can be turned into a fraction. Any whole number can be turned into a fraction, and any integer can be turned into a fraction. And what are irrational numbers? No. Those are numbers that cannot be turned into a fraction. Okay. All right. So the rest of it, I'll just leave it for you to do. Anyway, the answer is at the bottom of the page. Next, identifying radicals as representing rational or irrational numbers without determining the value of the radical. Identify whether it represents a rational number or an irrational number. Look at this one. Well, what the book suggested is a good idea, although, of course, I also have my own way, but let's go by what the book suggests. If you don't really want to find the final value of this, what it is saying is turn it into a fraction. Okay, meaning what's inside here, which is known as the radicand, you turn it into a fraction by thinking about place values. Well, there are four numbers after the decimal point. If there was a one number only after the decimal point, that is called tenths. If it was like this, two numbers after the decimal point, that's hundredths. If there were three numbers after the decimal point, that would be thousandths. And since there are four numbers after the decimal point, that is called 10,000ths. Therefore, if you turn this into a fraction, this is how it's going to look like. 16 over 10,000. And even without turning it into or getting the final value, we know that since one of the properties that we saw in the previous section is that you can split a radicand, if it's a fraction, into two parts, provided that you give the same index to both. This is what you can actually have, and you know that the root of 16 is 4, and the root of 10,000 is 100, which means it is a rational number. Okay, because it's a perfect square. I think that's what I was trying to tell you. Okay. So this one, rational. Cube root of 42. Well, it is not a perfect cube, right? So that's irrational. Okay. What about the cube of 512 or 512 thousandths rather? So let's try it again. Let's turn it into a fraction. 512 on top. The denominator would be what? The first number would be tenths, second number hundreds, thousandths, okay? That means you have a denominator of 1,000. If you divide the top and the bottom by 8, all right, that would be like this. So dividing the top by 8, dividing the bottom by 8, that would be 64 over 125. Oops. And 64 is a perfect cube, 125 is a perfect cube, so you know it will be a rational number. All right. Now, this one I leave for you to do. Okay. Now, if I could go back to what I said at the beginning, what the book is suggesting is to turn this the value, the number, the radicand into a fraction. Now that's a good idea. Although sometimes it is also helpful if you are able to be familiar with the numbers. Wherein seeing 512 and knowing that it is 8 cubed actually makes it a lot easier for you. So me, when I look at this 512 thousandths, and I'm trying to find the cube root, and I'm being asked whether it's rational or irrational, I already know it's rational because the cube root of 512 is 8. Same goes for this one. I know that would have a square root, which is 0.04. All right. So again, being good with the numbers, it will be very helpful. All right. So that's it for me for this section, and I'll see you next time. Thanks. Bye.